So these first two are rational functions. So if we compare the leading terms, and for me, I like to actually write it. It's just helpful for me. At the end, it behaves like this, which is equal to 2n over 5. But if n is getting ginormous, this is getting ginormous. Now you have to be careful here because the leading term is actually negative 5 over n squared.
Hey, what do you want? Sure, Jimmy. Can you go potty?
I'm making a video. It's my other daughter and my dog. Okay? Okay, now this one's got like another little riff in it. So you're actually cubing it. So if you cube this out, you don't care about anything but the leading term. And the leading term would be n cubed. But the leading term in the denominator would be 2n cubed. So this is n cubed over 8n cubed, which is an eighth. So that had a little bit of a trick there. Okay, so there's just some review and a couple of riffs on rational functions. Let's look at the next group. The next group are rational functions, but you've got this extra piece in here, and we talked about this. That's how you make the signs alternate. So you just have rational functions, you're generating outputs, except you're going to be having a pluses or minus. So let's look at this. This ratio of leading terms would be 1, but half your terms would be going to plus 1, and the other half of your terms would be going to minus 1. And since they're not going to the same place, we say that this limit does not exist, just like Lindsay Lohan, if you like Mean Girls. Okay, and then if you look at the second one, the ratio of the leading terms for the rational functions is n cubed over n to the fourth, which is like 1 over n. And if the denominator is getting ginormous, we know that that's going to 0. So it won't matter if we're a little bit bigger than 0, then a little bit smaller than 0, and a little bit bigger. So if you sort of think about it, you've got a little bigger than 0, and a little smaller, and a little bigger, then a little smaller. And so this is going like that. If you made a picture for this one, it'd be going like 1 and negative 1, 1 and negative 1. So this is still going to 0. Okay, now if you did this one, that rational function starts to behave like n cubed over n squared, which is n, which means we have ginormous outputs, and we would be alternating, like ginormous positive numbers, then ginormous negative numbers. And so if you sort of graphed it, half your terms would be getting really big, and the other half would be getting really small. So this does not exist. Okay, let's look at the next group. The next group is just a riff on what happens if you sort of change an exponential function. So let's kind of imagine doing this one. Let's see if we can just write it as an exponential function. That would be 5n over unadd the powers, 7 times 7n, which would be 1/7, 5/7 to the n. And if we did the same thing over here, we would have 7n over unadd the powers 5 times 5n. We can group these together. So that's 1/5, 7/5 to the n. Okay, what's the big thing you have to look at for an exponential function? You have to look at the ratio. So this ratio is 5/7, and this ratio is 7/5. And why does that matter? Because if the ratio is less than 1, this is going to go to 0, and this ratio is bigger than 1, and it's time. So this is getting infinitely big, and you're timesing it by a plus number, so this is going to plus infinity. Okay, now the last group is really all sort of using rational functions, but we're doing something extra with them. Okay, and again, all of these are looking at n behavior, because in a lesson or two, we're going to start looking at what happens if we're going to a different place. Okay, so if the n's going to infinity, this is going to, sometimes I like to write that, 1 over infinity is going to 0. So this is like e to the 0, which is 1. Okay, if we go over here, let's look at this part right here. And the leading term would be n squared in the numerator and 2n times n in the denominator, and that's a half. So this input's going to half pi, and the sine of 1/2 pi, we're up there, that's 1. Okay, let's look at this one. Oh, this one a little different. We're just rotating by pi. So we're here, then we're here, and then we're here, and then we're here. And so the cosine number alternates between a +1 and a -1. So we don't have a limit there. Okay, let's look at this guy. This is going to go to 0, and then we're going to add pi. So this is worth the cosine of pi, which is over here, which is -1. Okay. Now we're going to try in the next unit as we sort of head towards our end of our time together to practice more with logarithms. So let's see what you remember. So this approaches 2, and log base 2 of 2 is saying what power of 2 gives you 2? That number is 1. Okay. This is the same thing, but remember ln is a special version of writing log base e. So if n goes to infinity, the leading terms are the same. So this approaches 1, and this would be equal to the ln of 1. And that's saying e to what power gives me 1? And that answer is 0.